Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way to keep me going, inspired and refreshed. This problem was already solved by three-moment equations and slope deflection equations. Let's just verify the answers by computing internal moments at B and C. So let's have a strip first. So this is 24dx, and let's call that distance x. And on this side, let's call this distance x. So w as to x equals 30 as to 10. Therefore, 30 over 10, 30 over 3 is 10. Therefore, the height of this, the intensity of this loading is up to here is 10x. And let's call that 3 minus x. So therefore, this is 10x dx. Fixed moments for AB is integral of 2 plus x, negative integral of quantity 24dx times 2 plus x, then this is 4 minus x, so 4 minus x squared over 6 squared. So negative integral 0 to 4, 24dx 2 plus x, 4 minus x squared over 6 squared. And that is negative 42.667 kilonewton meter. Fixed moment VA, on the other hand, is positive 20 integral 0 to 4, 24dx 2 plus x squared, 4 minus x over 6 squared. That is 64.00 kilonewton meter. Fixed moment CD is negative integral of quantity 10x 0 to 3 times 1 plus x, 3 minus x squared over 4 squared. And that is negative 9.281 kilonewton meter. And fixed moment DC is positive integral 0 to 3, 10x dx 1 plus x squared, 3 minus x over 4 squared. And that is equal to 18.844 kilonewton meter. Let's now tabulate, but before that, let's have the stiffness of its member. For AB, because the moment at A is 0, then this is modified into 3/4 of 1 over 6. 3/4 of 1 over 6 is 1 over 8. BC, internal span, so just 1 over 5. And for CD, the far end has 0 moment, so this is modified again into 3/4 of 1 over 4, so 3 over 16. So tabulating, we have at A, the distribution factor is 1, so but let's make it negative 1. For BC, negative 1/8 over 1/8 plus 1/5, so this is negative 5 over 13. For BC, negative 8 over 13. For CB, negative 1 over 5 over 1 over 5 plus 3 over 16, negative 16 over 31. So therefore, this is for CD, negative 15 over 31 at the negative 1. Fixed moments are now placed. So we have negative 42.667, 64, for this span, negative 40 times 3 times 2 square over 5 square. You just calculate it right away, negative 19.2. For CB, positive 40 times 3 square times 2 over 5 square, and it is 28.8. Then CD, negative 9.281. DC 18.844. Then let's distribute. So negative 42.67, negative 1, 42.667. Quantity 64 minus 19.2 times negative 5 over 13. Negative 17.231. Replace negative 5 by negative 8. Negative 27.569. Quantity 28.8 minus 9.281. Times negative 16 over 31, negative 10.074. Replace negative 16 by negative 15, negative 9.445. and this is negative 18.844. So A and D are now balanced. Before carrying over, let's finalize the moment. So it's 0 here, it's also 0 there. So since it is already balanced, we don't need to carry over the half of negative 17.231 at A. Instead, half of 42.67 at B, which is 21.334. Half of negative 10.074, put it here, negative 5.037, half of negative 27.569 here, negative 13.784. And at D, it's already balanced, so its final moment is 0. We don't need to carry over half of negative 9.445 here at D, but rather half of negative 18.844 at C, negative 9.422. Then distribute. So quantity 21.334 times minus 5.037, close, times negative 5 over 13, negative 6.268, replace negative 5 by negative 8, the value is negative 10.0829. Quantity negative 13.784 minus 9.422 times negative 16 over 31, 11.977, replace negative 16 by negative 15, 11.229, and carry over. So since no more, we didn't touch here, so it's none here. Then here, half of 11.977, half of negative 10.029, and none here. Distribute 5.988 times negative 5 over 13, put the value here. 5.988 times negative 8 over 13, negative 3.685. Negative 5.014 times negative 16 over 31, negative 5.014, negative 15 over 31, then carry over, so none, half of 2.588 here, half of negative 3.685 here, then none. Distribute 1.294 times negative 5 over 13, 1.294 times negative 8 over 13, negative 1.842 times negative 16 over 31, negative 1.842 times negative 15 over 31. Carry over, so none, half of 0.9507, half of negative 0.7963 here, and none. Distribute 0.4754 times negative 5 over 13, 0.7475 times negative 8 over 13, negative 0.3982 times negative 16 over 31, and negative 0.3982 times negative 15 over 31. Carry over, so let's continue. Let's still consider this as important unbalanced moments. So none here, half of 0.2055, half of negative 0.2926, then none. Distribute 0.1028 times negative 5 over 13, place it here, times negative 8 over 13, place it here, negative 0.1463 times negative 16 over 31, negative 0.1463 times negative 15 over 31, then carry over, none, half of 0.07551 here, half of negative 0.60632 here, then distribute, so none there, then 0.03776 times negative 5 over 13, put the value here, times negative 8 over 13 here, negative 0.03163 times negative 16 over 31 here, then times negative 15 over 31 here. Carry over, so none, half of 0.01633 here, half of negative 0.02324 here, none. So let's have the final distribution. So we end up at distribute so that the left and right moment at the joint will have the same values expectedly. So 0.008165 times negative 5 over 13 here, then times negative 8 over 13 here, negative 0.01162 times negative 16 over 31 here, then negative 0.01162 times negative 15 over 31 here. So since they are consistently with double zeros from the decimal, so let's lock the joints finally. So final moment at A0, here you add the values in this column and you'll get 58.794 in this column, negative 58.794 in this column, negative positive 13.317, so here negative 13.317. In slope deflection equation and three moment equations, this value is negative 58.792, I think, and here negative 13.317. Therefore, moment at B is negative 58.794. Moment at C, negative 13.317 kilonewton meter. So that's it for this problem.